us how to do in class was how to factor what's called the difference of two squares, okay? So what this looks like is this looks like having a perfect square minus a perfect square, okay? So let's talk about things that are perfect squares. Okay. So let's kind of talk about this first. Let's kind of talk about, yes, these things are perfect squares, okay, as opposed to these things, which are not perfect squares. So, for example, numbers that are perfect squares would be like 4, 9, 16, I'm sure you reckon all of these, 25, 49, right? Because all of these numbers are the same number times itself twice. Now, variables like x squared are perfect squares. X to the fourth is a perfect square, right? Because it breaks down into x times x, or this breaks down into x squared times x squared. X to the sixth is considered a perfect square because it breaks into x cubed and x cubed. So what we see here are all of the numbers are perfect squares, but all of the exponents are even. Okay, so some things that are not perfect squares would be maybe like 2 or something like 10, right? So all these numbers that aren't perfect squares. X cubed, or maybe just a single x, or x to the fifth. So if the exponents are odd, they are not going to be perfect squares. So what we can do is when we recognize that there's a perfect square minus a perfect square, we can split this into two parentheses. And what's going to happen is the a squared is going to split up into a and a, okay? And then the b squared is going to split up into b and b. And it will split up perfectly because perfect squares always multiply to make the same thing twice. Now, if the middle sign is AB and the outer sign is AB, if you notice, there is no middle term because that middle term has canceled. So the only way to get this to cancel is if one of them is a positive and one of them is a negative. So the signs are always going to go plus minus. Okay? So let's run through a couple of examples. And let's start with kind of an easy one. Let's start with, for instance, x squared minus 16. Now we see that both of these numbers are in our list. X squared is a perfect square and 16 is a perfect square. So when we split it, we split the x squared into x times x, and 16 splits to be 4 times 4. Okay, we don't want to use 8 and 2, or else you're not going to get that middle term to cancel. Remember, if this is 4x and this is 4x, to get that middle term to cancel, one of them has to be a positive and one of them has to be a negative. So really, it's just a formula, okay? And once you recognize these, it's one of the easier types of factoring because they all factor kind of in the same way. Now let's say we look at an example like x squared plus 9, okay? And so we go to factor this, and I split the x squared into x, and I split the 9 into 3 and 3. Well, if we were to make our inner and our outer be plus minus, well, the problem is if we make it plus minus, a positive 3 times a negative 3 won't make a positive 9. So that's not going to work, okay? So what we would do is then maybe the next thing that students do is they think, okay, well, what if we change the signs to be plus plus? Well, then we have to think about if it's plus plus, then that's going to make a 6x in the middle, and that's not going to work, okay? Well, the reason that this is not working is because this does not factor, okay? And that is why it's called the difference of two squares, because there has to be a minus sign in between. All right, so don't be fooled with this and get going on autopilot. You can only factor if it has a minus in between. All right, let's take a look at another one. Let's do an example 3. Suppose we have 9x squared minus 25y squared, okay? Well, same thing. As soon as you recognize that this is a perfect square, we can split the first term perfectly into 3x and x. We can split the last term perfectly into 5y and y, and the signs are always going to go plus minus which is how you get that middle term to cancel. So hopefully you're looking at this and you're kind of thinking, all right, this is really pretty easy. And you're right, it is. We're not really guessing and checking. Okay. The last one I want to do is let's combine with what we've learned previously. So what we can do is we're going to look to factor out a GCF. Okay. None of the problems I gave you before had a GCF. And so what I see is we can factor out a 2. And when we do that, we're left with x squared minus x to the 6 minus 9. Well, I recognize that, again, this is the difference of two squares. X to the 6 is a perfect square because we can split it perfectly into x cubed and x cubed. 9 is a perfect square, so we can split it into 3 and 3. And the signs are always going to go plus minus, and therefore it is now factored. Okay, so that's the general idea. I hope you got all of these examples into your notebook, and we'll continue working on this concept in class. Thank you. Bye.